All right, welcome back to another video. This is the second of the three-part video in which I'm going to be talking about the derivatives of sine, cos, and tan. This time looking at the derivative of cosine and why that's equal to negative sine of x. So starting out, we need to recall the following three facts. The first two I proved in the first video. So we have that the limit as h goes to 0 is of sine of h over h is equal to 1. So we proved this one last time. We also proved the second one here, which is that the limit as h goes to 0 of 1 minus cosine h over h is actually equal to 0. And finally, this third thing that I've listed here is actually another one of the compound angle identities. So compound angle identity. Again, this is beyond the scope of methods, but if you're interested, I would recommend looking up videos to prove this theorem as well. It's very interesting. You can do it geometrically. It basically says that if we have two angles, so angle A and angle B, cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times sine of B. So we're going to use these properties in our explanation, and it's a very direct proof. Let's just start out by saying let f of x be equal to cosine of x. What we're interested in finding is the derivative f dash x, and we know by the definition of the derivative, this is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. So that's just the definition of the derivative. And if we just substitute x plus h into cosine of x, we're going to get the limit as h goes to 0 of cosine of x plus h minus cosine of x divided by h. Okay, now this is where we use that compound angle identity that I've listed up there. We go ahead and substitute that in for cosine of x plus h. So that's going to give us cosine of x. Maybe I'll do this in a different color. It's fine. So cosine of x times cosine of h minus sine of x times sine of h. So that is the cosine of x plus h bit. And then we've still got the minus cosine x at the end there, and that's all divided by h. Okay. So that's using the compound angle identity, which is the third thing that I've listed up there. So that's by 3. Okay, now we're going to look at that larger fraction, and just like last time, we're going to split it into a couple of smaller fractions. So the way that we're going to do that is we're going to first reorder this this sum. So we're going to change the order so that it is, let's write it as negative of sine x times sine h divided by h. And let's say we'll extend this like this before we split the fraction. We could write this as negative of cosine of x plus cosine of x times cosine of h. So all I've done there is I've just reordered that sum that's up the top of the fraction a little bit. Now I'm going to split that fraction. So we can write this as the limit as sine of h goes to h of negative sine x over sine h divided by h. Okay, it's just that first fraction. And then let's look at the second fraction here. So we have plus the limit as h goes to 0 of, now this second fraction here, what we're going to do is we're going to take out a common factor of negative cosine of x. If we do that for these two terms over here, that's going to leave us with 1 minus cosine of h, which is starting to look very similar to the second identity there, and that's divided by h. Okay, and now neatening up these limits again, we can see in that first limit we've got this sine x term which is not dependent on h, so we can take that outside of the limit. So this is equal to negative sine x of limit as h goes to 0 of sine of h over h, and that second one we can take out cosine of x because it's not dependent on h. That leaves us with the limit as h goes to 0 of 1 minus cosine of h over h. And a little bit similar to how we ended the last video, we can now see that that first limit the limit as sine h goes to h, we know from before that that's equal to 1. So you can see that that's equal to 1 based on identity 1 that we've written up there. So that's multiplied by 1 by that first rule that I've listed up there. And finally, we have that's equal to, so we'll make like a really large negative sign to keep everything above what we're working with. And this limit here, the limit as h goes to 0 of 1 minus cosine h over h, we can see up here that that's the same as 0. So that's multiplied by 0 by the second thing that we started out with here. And again, both of these limits were proved in the last video. So putting this together, we can see that the derivative of cosine of x is going to be equal to negative sine of x times 1, which is just negative sine of x. Take away cosine of x times 0, which is equal to just 0. So therefore, that will be equal to negative sine of x. And that is exactly what we wanted to show. The derivative of cosine of x is equal to negative sine of x. And as you can see, this kind of just follows immediately from the last proof that we did. So normally this wouldn't be called a proof of its own right. You're probably going to use a fancy word like corollary, which means that this is a proof which follows directly from the last proof. But that's it. So the proof that the derivative of cosine of x is equal to sine of x. Thanks for watching, and I'll see you in the next video.